Are you following me so far? Okay, 5.1 is on random variable and probability distribution. Random variable and probability distribution. Actually, I believe our textbooks say discrete random variable. You can read a little bit from your textbook about what is discrete random variables, but let me explain what is random variable first. Definition. A random variable usually denoted by capital X, but it can be other capital letter. Okay, it can be other capital letter, but usually capital X is a variable that has more than one numerical value. The word value is supposed to be numerical, but some other people define the word value for something else in statistics. Okay, each value with probability to occur, with a probability to occur. Now, I want to explain this random variable further, not just by definition, but random variable, the phrase random variable can easily be confused with sample space. But they are not the same. At least not in general. At least only in general. In some cases, yeah, the sample random variable happens to be the same to the sample space, but in general, that's not the same. Okay. Now, a sample space is a consequence of an experiment. So once you tell me the experiment, then we know what are the sample space. Now, for example, okay, little example here. Suppose I say the experiment tossing a coin twice, tossing a fair coin twice. So once you know that, oh, you know what, we do this experiment, tossing a fair coin twice, then the sample space is the consequence of that, you know right away. Then the possible outcomes are head then head, head then tail, tail then head, or tail and tail. Okay, so when you do this experiment, the sample space must be one of these 4 possible outcomes. Okay, and we learned from, I think around last month or 3 weeks ago that because it's a fair coin that you toss twice, then the probability for each one of them is 1/4. Probability of head, head is equals to the probability of head, tail equals to the probability of tail, head equals to probability of tail, tail, because the probability for the first one to be head is 1/2. The probability that the second one is head is also 1/2. Okay, or if you apply that to probability head and tail, 1/2 for head, another 1/2 for tail, right? Okay, now that's the sample space. Now random variable needs to be a random variable needs to be further defined from sample space. And don't forget, for our level, it has to be numerical. Okay, apparently from the example I give you here, head, 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 tail, tail, head, tail, tail, those are not numerical. Okay, those are not numerical. So for sure, it's not random variable. Yes, it is sample space, but it's not random variable. Okay, so what do you mean, Thomas, that you need to further define the random variable? Now, then from here, depends on what you want to measure. For example, we define let X be the number of tails occur. So when you do an experiment of tossing a fair coin twice, you want to see what are the possible number of tails to happen. Now, possibly 0, right? You see, when we say 0, it actually corresponds to this event, right? Possibly 1. That corresponds to these 2 events here. Possibly 2, which corresponds to this event. Okay, so the sample space here, because they are not numerical, they won't be random variable. Okay, now, but Thomas, how do you know that the X should be the number of tails? Well, you can define it other way. You can say, let X be the number of heads instead. Okay, yeah. Depends on what you need. From the experiment, you automatically, consequently will have a sample space, but then the random variable depends on what you are measuring from that experiment. Okay, now then I go on. I said earlier that a random variable X has more than one numerical value, right? So here we see X may be 0, maybe 1, maybe 2. Okay, you toss the coin twice, so at most you get 2 tails. Does that make sense? Okay, so when we say random variable here, it's not in the sense that random, that it can be anything. No, not in the sense that it can be anything. It can be 1, can be 2, can be 3, can be 1.5. No. Random simply means it has more than one value. Each value with corresponding probability. Okay? Not random in the sense that you just randomly pick a number. No, not in that sense. Okay, now then going further, I said earlier it has to be numerical value and each value corresponds to probability. So you see probability that x equals to 0 is what? What is the probability that the number of tails is 0? Now that corresponds to probability that you'd have no tail, right? That is if the probability are both heads, which is 1/4. Okay, probability that x equals to 1, that corresponds to either you have ht or th, right? Probability of ht or th. And for these events to happen, the probability is 2/4, right? And then probability that x equals to 2. What is x again? In this case, x is the number of tails. So probability of having 2 tails will be 1/4. Okay, so if I try to give you the diagram, it's basically like this. Once you know the experiment, then the sample space is a consequence. Now, for you to get a random variable, you need to have a definition first. You need to define it first. Thomas, what do you mean you need to define it? You need to know what you are actually looking for. The number of tails, the number of heads, okay? And then from that random variable, then later on you will come up with, as a consequence, direct consequence, something called probability distribution. What is probability distribution, Thomas? The word distribution, just like you have that before, remember frequency distribution? Now, frequency distribution is a table. Frequency distribution is a table in which the first column is the outcome and the second column is frequency. Now, you call this frequency distribution. Now, what is probability distribution? Probability distribution is the same table, except that the second column is, instead of frequency, you call it probability. Okay? And instead of having outcome here, now we have the random variable, usually denoted by x. So if I use the example I have above, we saw that random variable x has possibly 0, maybe 1, maybe 2, the number of tails, right? Now each one of them with corresponding probability. Now you remember from the past, the probability of an event has to be between 0 and 1. So everything in this column here has to be positive number at most 1. It has to be positive at most 1. Maybe 0, by the way, between 0 to 1. Now, on the top of that, the sum of all possible outcomes, therefore, the sum of all possible random variables supposed to be 1. Okay? Supposed to be 1. Now, let's see another example. Another example. let X be the number of passengers in a passenger car, let's call that a sedan, coming to a mall parking lot. Okay, of course I make up numbers. Okay, but it is possible a sedan has. Is it possible to have a -1 passenger? I don't think so, right? I don't think so. Uh, 0 passenger maybe? The driver must be there, of course, right? I'm talking about passenger. So let's say the probability to have 0 passengers is, let's say 60% or 0.6. Probability of having 1 passenger, let's say, so just a couple, husband and wife maybe, or boyfriend, girlfriend, let's say 0.3. 2 passengers, let's say 0.07, and 3 passengers, let's say 0.03. Okay, now of course I know I have to stop there because the total already 1.00 or simply 1. Is it okay? The total has to be 1. So in my test or in my quiz, for example, I may just leave one of the cell empty and you figure out yourself. You figure yourself what number should that be. But you know the total has to be 1. Why? Because it is a probability distribution. Once it is probability distribution, then the sum of the probabilities of all possible random variables should be 1. Okay, and then using this 1 together with the rest of these numbers, right, you basically do 1 minus the sum of 0.6, 0.3, 0.03. It should give you 0.07. Okay, it should give you 0.07. Now that's a probability distribution. If what happens if the total is not 1 times, then it is not probability distribution. Okay, if the sum is not 1, then it is not a probability distribution. So go back to this. Go back to this. Usually, we start from probability distribution, and then from there we go on computing 2 things: the expected value and the variance. Okay. Now in my test, I have question where I give you the probability distribution, and then you find expected value and the variance. There are also some questions I give you the random variable and you develop the probability distribution yourself. I also have questions that actually start from the experiment. I tell you the experiment and you need to go through all of this yourself. Okay, now the way I teach you right now for the rest of today is I will go in that order. Okay, I will go in that order. In this order, I will first now teach you how to come from probability distribution, going to find the expected value and variance. Definition and formula. The expected value of x or the expectation of x denoted by capital E parenthesis capital X as the random variable. Okay, so X is the random variable. The expectation of that, we use capital E and then parenthesis X, is the average of X if the experiment is done many, many, many times. Now the word many, many, many times here refers to a very big number. Well, what do you mean by very big numbers? Now, once you say a number, that's not enough. So even if you say 1,000 times, now it should be more than that. How about 3,000 times? Now it should be more than that. How about 10,000? Need to be more than 1 million, more than that. Okay. Suppose, for example, just to explain what is expected value in terms of average. For example, remember that tossing the coin twice, tossing a fair coin twice. Okay, and I want to find the actual average, okay? Then I toss it, I do this experiment, let's do it 10 times. Okay, so the random variable x is 0, 1, 2, and you toss this fair coin twice, and you do that experiment of tossing it twice, you do it 10 times. So the first time you toss it twice, you have 1 tail. And then the second time you toss it twice, you have no tail. The third time you toss it twice, you have 1 tail. And then 2 tails. And then 1 tail. And then 0 tails. And then 1. And on. And now, if you do it 10 times, you expect the average to be not far from, as we will compute that later on, not far from, in this case, not far from 1. Okay, now, but the expected value is when you toss it many times. Okay, so a lot larger than this 10. Okay. Let's say for example, suppose you toss it 10,000 times. Suppose you toss it 10,000 times. If you add all those numbers, right? In this case, 1 plus 0 plus 1 plus 2 plus 1 plus 0 plus 1 plus 2, so on, divided by, in this case, only 10 times, you expect this number to be not too far from 1. Okay, and I will tell you later on why we expect that to be 1. Now, if you make it a lot larger, 10,000 times, you take the average of that 10,000 times, you will see the average is actually even closer to 1. Okay, now the expected value refers to what is the average you get if you do this same experiment many times. Okay, now because it is this expected value of x or expectation of x denoted by ex is the average of x, then we also denote expected value of x by, we also denote the expected value of x by mu x. Expected value of x also denoted by mu subscript x, or if the context is clear, you can just call that mu, because it is basically the average. Okay, and the formula is given by The formula is given by the sum of px. The sum of px. Now, I want you to realize the following. Maybe we do this first. If I go back to example 1, my x are 0, 1, 2. The probability is 1/4, 2/4, 1/4. I purposely not reducing that 2/4 becomes 1/2 because I need to extend this table. Remember the first extension in the past? You multiply f times x, right? Okay, now we have p times x. That's 0, 2/4, 2/4 equals to 4/4, in this case is 1. Now, the expected value is the sum here. That's the expected value. The expected value of x is 1. Okay, so based on this probability, if you do the experiment many times, the average is 1. Okay, Thomas, so if I do it, let's say 10,000 times, if the experiment is done 10,000 times, you toss the coin twice, 10,000 times. What is the expected value? We expect the number of tails showing up on average is 1. On average, it's 1. If you do it 10,000 times and the average is 1, means in these 10,000 times, we expect 10,000 of them appears tail. What happens if I do it in 40,000 times, Thomas? The expectation is still 1. Therefore, 1 times 40,000 times is 40,000 tails. Okay, now let's do another example. I go on with the second example and then I give you a break. Maybe with some little example for you to do during the break. Example 2, the one that we have earlier, where x is the number of passengers in a sedan. I remember 0 is 0.6, 1 is 0.3, 2 is 0.07, 3 is 0.03. The total is 1. Now then, what is the expected value? What is the expected value? Now, in the past, for us to find the average, we need to know how many times the experiment happened. Right now, it turns out we don't need to anymore because we have probability distribution. We can find the expected value, we can find the mean by doing the first extension. I get 0.53. So the expected value is 0.53. Okay, remember what is this x here? Number of passengers. Right? Okay, that's the number of passengers. Now, what does it mean when we say the expected value is 0.53? It means on average, each car has 0.53 passengers. So, how do we use this information? So, if there are, let's say, 200 cars in the mall, in the parking lot. Then how many passengers do we expect? To be in the mall, let's say, then it will be 0.53 per car times 200 cars. We expect 106 passengers. Okay, now each car should have one driver. Okay, each car should be one driver. Then how many people in the mall? How many people do we expect? Not counting people coming on not bike sedan. Okay, just look at the sedan. Then we know there's 200 plus 106 people we expect. Can be more, can be less. Now imagine how do we use these informations? How do we use these informations in case that we have an earthquake? Let's say we have an earthquake and then the mall collapse. And we found out in the parking lot there are 200 cars. Then how many people do you expect to be in the mall, buried under the rumble, the rumble? Then from this computation, we expect 306. Maybe more, maybe less, but we don't expect to be too much more, too much less. Okay. In other words, if in case you do some rescue, right, and you find only 100 people, hopefully all of them alive, okay, then should we search more? The answer is yes, because we expect around 300 people is actually trapped under the rumble. Okay. Now, once you get around 300 people, everybody tired already. Can we rest? Yeah, get some rest. Okay, but Thomas, is it possible we have more down there, in there? It's possible. Okay, but sometimes we get too tired, right? And then we need some little rest. Okay, it's just a little example. Okay, in fact, I asked this kind of question sometimes in the past in my past 3. Where we put into this some computation on what is the probability there are actually 400 people in that mall or in that school or in that building. Okay, but that's the application. Let's go back. Don't go too far. We learn to find the expectation only. Now, using this knowledge, let me ask you to complete this probability distribution and compute the expectation. So suppose I have x to be 1, the probability is 0.5, x is 5, let's say is 0.2, is 10, is 0.15, and then 20. Let's say we have this table. I want to complete this first, so you need to find this and this. Okay, and then find the expectation. Do you think you can do this? If I give you, let's say, 3-4 minutes? Okay. Okay, nobody say anything. Okay, I give you a break together with this. We come back. Oops. Okay, so yeah, the total has to be 1. Therefore, the probability for 20 is 0.15. I can put some storyline here. Suppose for example, you are told to spin. You go to casino and then you are told to spin this wheel here, and half of that is, let's say, half of that is $1. Let's say. And then 0.2, so approximately this big here is $5. And then it should be bigger though. I try to make it like approximately 20%. So let's say like this. And then the other wheel, the other part, $10, $20. $5 here, and $10 here, $20 here. Okay, so you spin it, and then they put a, let's say they put a pointer somewhere, you know, you spin it, whatever the pointer land, that's how much money you get. Okay, then suppose from the area you find out then corresponding area to the probability, then what is the expected value? If you spin this wheel, let's say many times, then on average, what do you expect to get? So this will be 0.5, this is 1.0, this is 1.5, this is 2, the total will be 5. Happens to be a nice number, but doesn't have to be a nice number. Okay, so in long run, the expected value of you spinning this wheel is $5.
Professor, for 20 times 0.15, I got.
Oh, it should be 3, huh?
Yeah.
So it should be 6 here?
Yeah.
Good, thank you. Yeah, I don't want it to be 5 because it sounds like it is one of the outcome. Thank you. Okay, so in the long run, the expected value on average, so when somebody spin this wheel, the average outcome is 6. Okay, now suppose then later on we play this game, then and we spin it 1,000 times. Okay, then what is the total numbers we get, or total money being spent out? Then we expect that to be $6,000. Okay, if you spin it 1,000 times, then we expect the dealer to provide the money will spend $6,000 on expected value is $6,000. Okay, so instead of like first finding out that you will spin it 1,000 times, just find the expected value first, and then see later on. Oh, if I spin it 10,000 times, then you should prepare $60,000 times. Okay, now just little extra informations. If this is the expected value, then how to make this game? If this were a game, like a gambling, you know, and then whatever the pointer land, that's how much money you get, right? Of course, if you don't need to pay anything to play this game, then you will always win, right? In fact, you will always win at least $1. On average, you will win $6. How to make this game fair? Now, a game is fair. A game is fair. Maybe I use red color. No. A game is fair if the expected value is 0. If the expected value is 0. Now, so how to make this game fair? Well, whoever wants to spin this wheel needs to pay $6. Okay, because you expect to win $6, right? Okay, so if you want to play, once you spin it, you need to pay $6. Now, then you start thinking, right? If I don't need to pay anything, I will win at least $1. Does it make sense? Right? Okay. Now, once you start that you need to pay, then you start thinking, well, I have the probability of 70% probability of getting less than $6. Okay, but when I win more than $6, that I win a lot. Actually, the $20 one is the one we put our eyes on, right? Okay, I have 15% chance to win $20. Okay. This then later on being brought into the casino game. Basically, in casino game, the expected value will be negative for you. In casino game, expected value will be negative for you. Let me pick a question from our book. I saw a question like that earlier. Give me a sec. Actually, there are two questions like that similar to that I would like to go over. There are word problems, so you may think that's a hard question, but the idea is actually quite simple behind it. And on the top of that, it's also quite applicable. Number 28 in 5.1. Let me quote it. So for people who wants to learn gambling a little bit, I hope then here you will see why I do not recommend you to gamble unless you are the dealer. So be the casino, be the dealer, don't be the player. Okay, so under what situation, Thomas, you will play? Well, I play if I don't mind to lose that much money. When I go to casino, for example, oh, I love this Venetian. I love this Venetian. Every year they give me 3 days, I should say 4 days, 3 nights free room every year since 2016. And it's usually in April. It's usually in April. They asked me, Thomas, which days you would like that to be actually throughout the year. I said, well, I don't like to come when it is very, very crowded. So let me go there during my spring break. Okay, so it's April. This year, I didn't go in April. They say, oh, hey, you know what? In September, we have a blackjack tournament. Will you come? I say, no, I'm not coming. Maybe next one. And then they say the next one is December. Will you come? I said, maybe I come. Okay, but before I come, tell me how many days you give me. So, well, it's the tournament will be 2 days, but I can give you 4 days. I said, fine. Great, I take it. You know, well, so I'm actually doing promotion for Venetian. No, actually I get Golden Nugget also. Golden Nugget also give me rooms. Okay, let's see. When playing roulette at a casino, it doesn't have to be Venetian. A gambler is trying to decide to bet $5 on number 27 or to bet $5 to the outcome of any of these 5 possibilities. From example 6, we know the expected value is this. For $5 bet, that outcome this, there is probability this one with this profit, and this one with this probability losing. Okay. And then part A, find the expected value for $5 bet on that outcome. Let's see first. So even though the outcomes is this for part A solution, for part A. even though the outcome is 0. So the outcome are 0, 0, 0, 1, 2, 3. Okay, but that's not the random variable. The random variable will be the profit, right? Let X be the profit, how much money you make. Okay, now in this case, you will see X is either $30 or -5. Now that -5 if you lose $5, if you lose your bet. Okay, now how to find the expected value? To find the expected value, we need to first, I recommend, sometimes you can do it in one line, but I prefer you to actually go back to the probability distribution. The payout of $30 have probability 33 over, I'm sorry, 5 over 38, right? From here, the probability of 5 over 38 in making a net profit of $30. 5 over 38. Okay, now to lose $5, the probability is 33 over 38. Notice that the total should be 38 over 38, which is 1, right? Okay, now then, what is the expected value? Multiply this. And when you multiply with fractions, I do not recommend you to change it to decimal. No, no. Just multiply it this way. You see 3 times, this is algebra though, 3 times 5 over 38. That's the same to 30 over 1 times 5 over 38. So multiply the top, leave the bottom. Do you see that? Now this way you don't go into decimal, which very likely have rounding too early. Okay? And then the next one is -5 over 1 times 33 over 38. That's -165 over 38. -165 over 38. Now when I add them, I get -15 over 38. So the expected value of profit okay, or we call that expectation of X because we define X to be the profit. You can also write it as mu sub X. You can also just write it as mu equals to -15 over 38, which is, then you use your calculator. (15/38) is -0.39474 in decimals. Okay. Now, what does it mean? What does it mean? Interpretation. For every $5 bet on these numbers, zeros, is it 0, 0? No, 0, 0, 0, 1, 2, 3. Every time you bet $5 on these numbers, okay, the player expect to lose 0.39474 dollars. So if you bet, let's say 1,000 times on these 5 numbers here with $5 bet each, then you expect to lose 1,000 times this number. From casino's point of view, this is the cost of their entertainment. Now remember, casino in their legal when the city or the county asks them what kind of field you are actually, what type of business you provide, it is actually casino. They do say that it's casino, but the category will be entertainment. Okay, now this is the cost of entertainment in the eye of a casino. Okay, you call that lose. Okay, they call that entertainment. You need to pay us to entertain you, right? Okay, yeah, of course you may lose all $5, but at times you also win $30 if you do it that way. Okay, on average you will lose 39 cents with some little change each time you bet $5 on this. Okay, now the thing is, of course, if the expected value for you is positive, it means it is negative for casino, right? If the expected value for the player is positive, then the expected value for the casino will be negative, which means in the long run, casino will lose money. If that's the case, what's the point of them doing business, right? I hope that explains why casino game supposed to have negative expected value for player. Maybe I write it in graph. This expected value of profit, which is negative 0.39474, is the expected value for player. Then this will be the opposite, which is positive 0.39474, is the expected value for casino. Okay, now imagine roulette. I wonder if you know what's roulette. Now it's possible some of you still under 21, therefore you cannot go to casino. Let's see if there's any. Yeah, this is a roulette wheel look like. Maybe I pull one of them up. Yeah, this is the roulette wheel. I wonder if I make it larger. Oh, this is a Russian roulette or a British roulette. No, not this one. I don't want this. American roulette. American roulette has 2 zeros, the 0 and 00, and the numbers is actually between 0 to 36. Maybe roulette, instead of roulette, wheel will get roulette table. The place you put your bet on. No, I'm not buying it. This one maybe. Okay, so you see this roulette table. There are two, 1, 0, and 00, and then numbers from 1, 2, 3 all the way to 36. Okay, so there are 38 possible outcomes. Each one of them equally likely. Okay, each one of them equally likely. Now, if you bet on those 5 numbers, on the 0, 0, 0, 1, 2, 3, those are 5 out of 38 outcomes. 5 out of 38 outcomes, right? So if you go back to the question, if you back to our question, you see that explains why the probability that you win $30 is 5 out of 38. Okay, you will lose your bet, which is $5, if the ball lands on other numbers. Okay, now the thing is, when you play roulette, the more players playing will be better, and they are usually required to bet at least $5 each time they spin the wheel. Okay, so assume, if I go on further, you don't need to know this right now, okay, but if you are interested in doing business, then you assume 6 players play at the same time. Roulette game. Each with $5 minimum bet. So each spin, every time they spin the wheel, the expected profit for these 6 people combined will be 6 times negative 0.9, I'm sorry, 0.39474. That's the expected profit of the players, right? Okay, now the expected profit for the casino is the positive part. For casino, the expected profit will be the opposite. Let me look at my calculator, multiplied by 6. I get 2.36842. Now the thing is, one time they spin it, it takes like approximately 5 minutes. You spin it and then you pay it, so on and so forth. So per hour, get 12 spins at least. So if the dealer moves too slow, then the pit manager will tell the dealer, you need to do it faster. Okay, because the casino needs to make some money to pay for the dealer, right? The one who spin the wheel, for the pit manager, and a lot of other things, electricity, blah, blah, blah. Okay, so that will be 12 times 2.36842. So per hour, they expect to win, to make $28 something. Okay, now the thing is, you and I, when we go play and we lose $5 and $5 and then $5, guess what will happen the next bet? You tend to bet more. Why? Because when you lose a little, you want to get it back, right? So very likely not only very likely, it is nearly guaranteed that nobody from these 6 players, nobody of these 6 players will bet $5 only every spin. At least one of them will bet more than $5 eventually in this 1 hour, right? So on the expectation will be each roulette table will make approximately $28 per hour. Okay, that's for roulette table though. That's for roulette table. Okay, for example, for blackjack, of course, different computation. Okay, now at least what you need to know is this part here. The one that I need you to know is the one here. You need to know this. In fact, you need to know how to set it up. Okay, you need to know how to set it up. Can I go on to the next question?
Yep.
Okay, I will go to next question about life insurance. Life insurance is, oh, actually, I need to answer part B first. I didn't answer part B yet. That's only part A. Now part B, which bet is better? A $5 bet on number 27 or a $5 bet on these 5 numbers? Now we see for part B, let me just answer it next to it. Look at the expected value. Expected value for the profit on number 27 only is, as they tell us, is negative 26 cents, right? While the expected value, the expected profit on number 0, 0, 0, 1, 2, 3 is negative, what, 39 something, 39 cents approximately, right? Yeah. Okay, so which is better? Yeah, both of them losing though. So if you ask me what will be the best, don't even start, right? That will be the best. Okay, don't even start. But if you really want to play, okay, now this is half joking. This is half joking. If you really want to play, use somebody else's money, right? So you get the joy of gambling, but when you lose, you don't lose your money, right? Okay. Now that's part joking, but it is also possible. You see, also it is also possible. Ask my wife. No, my wife never gambling. I'm kidding. You know, but if you gamble using somebody else's money, you tend to be more stable psychologically. So you will see those money managers. It's better to trust your money to money managers to do your mutual fund, for example, compared to you doing it yourself. Why? Because if you're the one controlling it, usually you look at the loss and you kind of like being impulsive. While if a money manager, it's not their money, right? So they can be more realistic, more scientific, and less emotional, less impulsive in working on your in managing your money. Okay, but at least from this example, if I have to choose one of these 2 scheme of betting, then I prefer to bet on one single number instead of 5 numbers. Okay. Now the next one that I want to do is on life insurance. Life insurance works even until now. The life insurance is considered a controversial issue in Indonesia. Right now it's much better. Okay, but in Indonesia, like 20 years ago, it's bad. Like life insurance, if you buy life insurance for your, let's say if my wife buy life insurance for me, people will say that my wife expect me to die and get money from my death, you know. But it's actually, the idea of life insurance is not that. And of course, I suggest you to have life insurance, okay? Let's do this problem first and then we talk more about that, okay? Number 30 in our textbook, 5.1, there's a 0.996 probability that a randomly selected 50-year-old female live through the year. Basically, get to the 51st birthday. Okay? Now, a Fidelity Life Insurance Company charges $226 for ensuring the female will live through the year, and if she does not survive, then the policy pays out $550,000 death benefit. Okay, now the question is, from the perspective of the 50-year-old female, what are the values corresponding to the two events of surviving or not surviving? So part A, the sample space is, for a 50 years old point of view, female point of view, the sample space is surviving or not surviving. Survive or not survive. But that's not the random variable though. Okay, they were talking about the random variable, the values corresponding to that. Then the random variable x, let x be the payout. Okay, then that will be, if she survived, how much money she lost. She will lose, for survive, she will lose $226, right? If she survived. Now, what happened if she died? Then, if she dies, then the payout will be 50,000 minus that $226. Well, for you to be in the program, you have to pay 226, regardless you survive or not, right? If you survive, you don't get that money back. If you don't survive, you'll get only 50,000, right? So basically, the values corresponding to that is negative $226 if she survives, or $49,774 paid to her estate, the children maybe, if she passed away. Maybe I use $sign here. That's for part A. Now part B, what is her expected value? Now then I need to create a probability distribution. That's if she survived, with very big probability, of course, you expect that, 0.9926. 9968, 0.9968. Now the probability that her estate, not her of course, her estate will get the $50,000 is the remaining value, the remaining probability. It needs to add up to 1. So this will be 0.0032. Does it make sense so far? Now the question is, what is the expected value? Now, do you expect this to be positive or negative? Don't forget, for every positive expected value for this 50-year-old female, it will be negative expected value for the company. for the insurance company. And negative expected value for the insurance company means the insurance company expect to lose by insuring this 50-year-old female, to lose money, right? Okay, so we expect it to be negative, which means it will be positive for the company, right? And gives the reason for the company to run the business, okay? So Thomas, if this is the situation, you say that it will be negative expected value for the 50-year-old female, then what's the point for her to purchase this policy? Well, most of the time, it's not really just about this $50,000, okay, but to give some protection to the family for in the event of her death, okay? We call this risk management, okay? Now, I said earlier that I would like you to have life insurance, okay? Now, but under what situation you need to have life insurance? Especially if you are the breadwinner for your family, okay? I myself already, I did my PhD in probability and statistics, I say, right? And I actually have passed the actuarial test. Okay, you find this out for those people who think your math is actually, if you think probability is interesting, statistics is interesting, try to find this out, actuary. Type, Google it, find out what is this about, okay? But I want to tell you that actuary is one field in the whole world that has negative unemployment rate. Now listen to this. This is a field that has negative unemployment rate. Not only low. So if you are an actuary, okay, if you are an actuary, the chance is you are employed. When they say negative unemployment rate, means they need so many actuaries such that even those people without the certificate, they even hire as an actuary to fill up the position. Okay, and this is one of very, very few fields in which you don't need a diploma, you don't need a degree. You just need to pass the test. Once you pass the test, you get the certificate. With that certificate, then you can work for insurance company, or fund company, mutual fund company, or a lot of other things. Okay, now try to find out about this actuarial test and the money correspond to this. It's a very good money, trust me, it's very, very good money. It's very, very good money. There are 3 basic tests. I think the first one is XMP, they call it, that's the first test. The second test is exam FM, financial management or finance something. And then the third level, I forgot what's that. I passed the first one. And my my salary offer was 150K. Yeah, I passed that with perfect score. One of the job offer I get is 150K. I didn't take it, it's big though, but I didn't take it because it needs me to relocate to New York. If I relocate, they will add $50,000 to that just for relocation. Notice that they did not ask me for any degree. They don't say, oh, you need to have a bachelor degree. No, you already have the certificate that you pass XMP. This is what I offer you. You know? And if you pass the second test, I know it's at least 200K, at least 200K. There are only 2 people, as I know, in the whole United States pass all 7, the first 7 tests. And the person, I know somebody who passed the second test only, but he works for some companies and he makes $2 million because he works for some company at once. if you have this certificate, then you are able to write an insurance program. I'm not saying to the agent to sell the program. No, they're the one who make the program. So let's say I have the certificate, then I can set up a program, and then I sell this, for example, to Blue Cross. If Blue Cross look at that and, hey, you know what, we like your program, let me buy it. Okay? And they will pay $1 million for that. You know, the thing is, they cannot accept your program if you are not certificated. You see? Okay. So I'm talking from somebody with some little background, not a lot, little background in actuary, and talk about this insurance here. So we do expect this to be negative. Let me use my calculator. 226 times 0.9968 is negative $225.2768, while 49774 times 0.0032, that's positive 159.2768. When I add this, I get negative $66. So on average, for each 50-year-old female insured with this program, that female or her estate will lose $66. But that $66 is to provide $50,000 to her estate in case of her death. Now, I myself insured myself such that in case of my death, because I'm the only breadwinner, my wife's not working, okay, of course my children's not working. In case of my death, my insurance will pay my wife approximately $500,000. Why $500,000? Because that's basically what I owe. I'm still paying for my house. Okay, that's what I owe for my house. I'm still paying for that. Plus approximately 4 years for my wife to recover and get a stable job and still able to take care of my children. Okay, of course I cannot provide an insurance that in case of my death, then my wife can live without working for the rest of her life. That's way too expensive. That's way too expensive. Okay, but I think in case of my death, with 2 children, at least the house will be paid off, and she has extra money to continue with her life for 4 years. Hopefully she can find someone who can take her in and take care of my children also. Okay, but even if she decides to stay by herself, single mom, and she has 4 years to actually get a full-time job and live stable. Okay, yeah, this is in sense of risk management. Okay, let's see part C, what part C says. Can the insurance company expect to make profit from many such policies? Like what I said earlier, the expected value for the payout, this is for the insuree's point of view, is negative 66. For I should not say insuree, insured. Now the opposite will be the expected payout, and therefore will be the profit for the insurance company. If you spend some money, somebody need to get it, right? Okay, and that's for the insurance company. Now, if a company only sell one policy, one such policy, $66, that company should quit. You know, with $66 profit only, no, it's not good. Okay, but that's why they actually use this word here, many such policies. Okay, if this company sells a lot, let's say 100 such policies, then they expect to make $6,600 from these 100 policies for 50-year-old female. Okay, now I have approximately 15 minutes left. Let me go on. Beside expected value, there's also a variance definition. The variance of a random variable denoted var parentheses random variable x. You need to use that random parentheses x, or sigma squared subscript x, or if the context is clear, sigma squared only, is given by the formula is the sum of px squared minus the square of the sum of px. Little note to help. You know what? I do the table first. Let me do the table first. Suppose I use example 2. Suppose I use example 2, the cars, the number of passengers. Example 2. Zero here is 0.6, 1 here is 0.3, 2 is 0.07, 3 is 0.03. The total is 1, right? Now we did the first extension earlier. That's 0, 0.3, 0.14, 0.09. The total is 0.59, such that the expected value is mu sub x is 0.59. Then what will be the variance? Then we need to do extension. I already get this so far, this one. But I need to get this, right? Now for me to get that, I need to have x squared first, and then px squared. So I hope if you memorize how to do that procedure, the one you saw in your test, then it should not be too hard transition for you to do it here. This will be 0, 1, 4, 9, right? I square from here. I square it. You see what I mean? Now then, multiplied by the probability, I will get 0 here. Multiplied by probability, that's 0.3 here. This is 0.28, 0.27, with the total of 0.85. So the variance of x is now the sum of px squared minus the square of the sum of px. Of course, as we expect, the variance has to be positive all the time. Now, the standard deviation denoted by sigma subscript x, or simply sigma. Okay, but not this, not SDX. No, it's not. This is not one of the acceptable notation for standard deviation of random variable X. No, only these two. Okay, that will be the square root of this ugly guy, just like before. That gives us 0.70845. How do we use that? That's something else in future. On next Friday, I will teach that. How do we use these numbers? Okay. It has something to do also with the twice standard deviation away from the mean, the rare event, so on and so forth. Okay, now that's how we get the variance and therefore the standard deviation of a random variable. Now, in the last approximately 10 minutes, I will do, is it 10 minutes? What time I should end? I forgot. Is it 1:35 or 1:40? I forgot. You know what? Let me just end it here. Let me give you suggested homework from 5.1. That will be from number 7 to number 15, and then number 27 and 29. Okay, that's your suggested homework. Do you know when is our next test?
I think it's at the end of October.
At the end of October, 3 weeks from now. So from one test to the next test, you have 3 weeks. However, next week, we will finish 5.2 and 5.3. Next week, we finish 5.2, 5.3. Okay, now I will post now. I guess next week I will give you the. Do you want a homework that does in 2 weeks, or I will post it next week that does in 1 week? Which one's better? I will just post it, okay? But it will do it in 2 weeks instead of 1 week. Okay, then that's for today. See you next week.
All right, thank you.